I'm going to look at the first problem here real quick. So obviously, you could totally divide this into calculator, but if you didn't have a calculator, what's the quickest way to make a fraction become a percent or even a decimal? How do I make this become a decimal easy? Yes?
I multiplied it by 2 to make it 6 over 10, and then it would just be 0.6,
Yeah.
which would be 6%, or 60%.
60%, yeah. So all a decimal is a fraction that's got a multiple of 10 on the bottom. So if I give you a fraction, what was the quick way again to tell if a fraction would become a terminating decimal? If the bottom only has 5s and 2s. And this one only has a 5, so it should become a terminating decimal. If I multiply that by 2, I get 6 over 10, which is 0.6. Now, if I multiply top and bottom by 20, I would get 60 over 100, and that becomes directly, because what's per 100 mean? Percent. So that just is, if I just read this, if I know that per 100 means percent, that'll be 60%. Or you can move the decimal once, twice, so you gotta add a 0, right? So you have a few different ways to get there. Okay. How you guys feeling about that? So all decimals are fractions that have multiples of 10 on the bottom. They are fractions that fit into our base 10 number system. That's all decimals are. Percentages, you know, we made up everything. Humans made up what the symbols for numbers are. We made up our number system. You saw other systems, whatever. But percentages are kind of like extra made up. They're just decimals. We didn't want to look at the decimals, so we made percentages mean out of 100, so that makes them more whole, right? 60% is kind of nicer to look at than 0.6. How do I go from a percent back to a decimal?
Move the decimal over 2 spots.
Yeah, back twice, 1, 2. And that tells me what place I'm in for the fraction, right? That'll be 42 out of 100. And very often on these kind of problems, I actually don't want you to reduce. If the reduced number is just sort of there, very often what that tells me is you know where the fraction button is in your calculator, because it will give it to you as a reduced fraction. So I'd much rather actually see the unreduced, straightforward, this is what it becomes. You guys kind of with me? I might even say that on the test. Don't reduce these, huh?
Sorry, so you don't want us to do like the lowest, like the lowest we can go, just keep it the
It
lowest?
doesn't make sense why. In general, you should always reduce the fraction you get. But what I will get is I will get the right answer out of nowhere because they know where the fraction button is. And the calculator will give you the lowest terms.
Yeah.
So I'd actually rather see 42 over 100 here. Or at least, and now you could reduce it if you wanted to. But I want to see 42 over 100, so I see where it started. Yeah. So what about this dude? As a fraction, this is relatively easy. What's the shortcut to tell what goes on the bottom instead of, you know, tens, hundreds, stuff? Somebody know the shortcut? Count. Yeah, how many decimal places are there? 4. So how many zeros am I going to have? 4. Now you can go tens, hundreds, thousands, 10,000s, and that's what I ended up with, but it's kind of a nice way to do it. How about as a percent?
0.97.
Yeah, I gotta move this twice. And I put it in alphabetical order so it actually tells you the direction you go as you move in the table. So 0.97%, which is appropriately tiny because 0.0097 is tiny. Okay, you guys doing all right? Okay. And then I don't care what the percentage is. How do I change it back to a decimal? Move the decimal twice back. Why does it make sense I got a number bigger than 1?
800.
Because I started with a number more than a percentage more than 100%, right? So as a fraction, there's a few different ways you can tell me the fraction. Somebody give me one way to give me the fraction equivalent.
I did 8 and 13 over 100.
8 and 13 hundredths, and what's the other way to do it? This is 813 over.
813 over 100.
Yeah, right. And some of you guys realize I like the way you said that. Those are the same damn thing, but it's two different ways to look at it. Okay. I like it. And then suddenly I make it really easy again for some reason. 0.8, what is that as a fraction directly?
8/10.
Yeah, 8/10, I'm in the tenths place. And as a percentage, 80%, I like it. And then 5/8, technically what should you do with this? Yeah, you could long divide, or you can remember, we talked about fractional equivalence. Does anyone remember what 1/8, well, what's 1/4 as a decimal? 0.25. So what's 1/8 as a decimal? If 1/4 is 0.25, what's 1/8? How is it related to 1/4? 1/8 is,
1.25.
yeah, it's half of it. So if 1/4 is 0.25, 1/8 is half of that, 0.125. You guys with me so far? And I know you're all saying, Jeff, we got this thing called a calculator. It might have been invented after you were born. Be quiet. No, it wasn't. 4/8 is what? What's 4/8? 0.5. And 1/8 is 0.125. So what's 5/8? 0.5 plus 0.125. So 0.625. Or you just long divide, or you can chug it on in your calculator. Okay. And then percentage, that would just be 62.5%. I like it. So again, percentages don't help us out mathematically at all. They don't help any math. They just help us think about these things better. Instead of looking at tiny little decimals, I can kind of grasp 50% better than 0.5. All right, this one, stay with me now. Very often I'll have somebody do 40 divided by 3. Is that good? You can tell by the way I've said that, asked that question, but is that good, 40 divided by 3?
No.
If you had a student do 40 divided by 3, do you know why they might do that? What should it be, real quick? 3 divided by 40, of course. So why do you think a student might actually say 40 divided by 3?
Because it came before the 3?
Say again?
Because it came before the 3 and like the equation.
Oh, okay. So the order that it came in could be. Very often students know what operation, they just sort of do the numbers. Why else? Instead of 3 divided by 40, they do 40 divided by 3. Because 3 goes into 40. You know, not evenly, but it goes into 40, yes? So you can't blame them too much because their brain just says, dude, you can't put 40 into 3, man, but you can put 3 into 40, so it's got to be about the same number, right? No. Now, can you guys come up with the way? You've seen me do this. You just saw me do this a minute ago. Because I know you can put 3 divided by 40 in your calculator. Whoop-de-doo, I'm not impressed. Pushing buttons. Can anyone come up with a way just to do that by hand? Instead of long dividing? What do you wish, instead of 40, what do you wish I had put there? 30 would have been great, yes? Because then 3/30 reduces, it becomes a decimal, which I can make it into a percentage. Even 20, why would 20 have still been good? Why would 3/20 have been good? Because they're going to make that something out of 100, which I can make into a percentage quick, yes? So, 3/20 is exactly half, twice as much as what this is asking. So if I figure out what 3/20 is, I can then take half of that, and that'll be my answer. So if I do 3/20, how do I make that into a percentage? Somebody's phone's blowing up. How do I make that into a percentage without long dividing? Multiply by 5. That would be 15%. But that's not our answer because we want 3/40. But like we just said, 3/40 is exactly half of this. So what's half of 15%?
7.5.
And those of you who just plugged in your calculator, yes, we did finally catch up to you. So if you do 3 divided by 40, you should get 0.075. And then of course you make that into 7.5%. I like it. Okay. Oh, all right. I don't know if everybody's had a chance to try these out yet. If you haven't done these yet, go ahead and try them out. They're each basically the same idea. And this is definitely, I would let you use calculators like on part B for sure. Right. Yeah, sort of. Oh yeah, so instead of doing like is over of, and you can argue that's an equation, I mean straight up, word for word. So for example, that first thing is, what is 45% of 200? So when you see the word what is that in algebra? I don't know what it is, so what do we call it? X. Is equals 45%, 0.45 of 200. What does of mean? Multiple. So that is translated from English to Mathish, straight. And then you just have to do what that says, right? And if I do this, let me see. I know you guys plug this in the calculator, but if I move this over twice, and I move this back twice, 45 is 90. Which is the answer, right? Because that's sort of using the fraction approach. What is 0.45 as a fraction? 45 over 100. 100 goes into 200 twice. I really want this to be, I'm kind of using compensation. If I take 100 away from 200, I'll leave 2. And if I give it to 0.45, I make it 45. 45 times 2 is easy.
I had like 45% of 100 is 45 and times 2.
I love it. So you can also base everything off of 100. And so out of 200 should be double. I love it. Kick ass. Okay. So beyond just the basic idea of something, I would hope that you have a way of looking at these things that's your own. Because that's one thing you can give to your students. It's kind of like, here's the way I look at this. Just one more example, because a lot of things students don't get is some flexibility. They don't see that you can think about things in different ways. So it's really good for them to see, oh, that's how this person, so here's how you do it. This is by the book. But then here's kind of the way I think about it, and you can see how it works. So it's just, they need to see more flexibility in what they're doing. So who's got this one? How does this translate into an equation? 72 equals, don't know, times, and how do you solve for x? Divide by what you don't want there, yeah. And I think that should be like 0.50 something.
533.
What is it?
I got 533.
333, okay. I'm cool with it. I'm trying to do it in my head, so I'm cool that I'm that far off. And what is that as a percentage?
53.3%.
And it says round to the nearest thousand, so I really should be. By the way, when I say round to the thousandths place, I mean that as a decimal. So when I translate it to a percentage, it's to the tenths place as a decimal. Now, to be honest, I'll tell you on the test how much I want you to round, where it makes sense. Yes. So part C really works the same way. So it's if you truly hate algebra, oh my God, that's bad, because you have a very high chance of being given a grade to teach where you will have to teach some kind of component of algebra. So hopefully, you get over that if you are there. But the algebra required to solve these things is very minimal. It's kind of like the very first thing you learn when you're learning how to solve equations is the equations. You end up with this. How do you relate C? How do you translate C into an equation? Two equals 5% is known as what? As a number. 0.05. Times, I don't know. So when you translate, you got to translate everything. So the 5% as a number is 0.05. 5% is something we made up on top of the numbers. And then I just have to divide by 0.05. And if I want to do this in my head, I move this over twice, I move this over twice. 200 divided by 5 is 40. Now real quick, let me see if you guys are going. 2 is 50%. Oh, sorry, go ahead.
So, since you said to solve by translating it into an equation, if I did it a different way, would it?
How'd you do it?
Well, so if 2 is 5%, I knew 4 was 10%, and then I multiplied them both by 10 to get 40. Like,
Oh yeah, cool. I don't know. I would love that, but if I specifically said
Yeah.
translate into an equation, I'm testing that skill.
Yeah.
So I would probably take off something for that, but I mean, little cheer for that. So I was about to say a completely different way, but you just hear, she said, okay, if 2 is 5% of something, 4 must be 10% of that thing. Does that make sense? So there's some amount. If 2 is 5% of that amount, 4 must be 10% of that amount because 4 is twice. Does that make sense? And then she realized, okay, 10% of something just moves the decimal back 1, so it must have been 40. The way I was going to think about it is, 2 is 50% of what? 2 is half of what? 4. Therefore, 2 is 5%. 5% of 40. If I make this go down by a factor of 10, this has got to go up by a factor of 10. So both of them are kind of like playing with the numbers a little bit. Are you guys at all with me here? Okay. I know you can get the answer directly. The more you stop and think, what other ways could I do this, the easier it will be for you when your students do those other ways. Because very often a student will do something, I'm like, I didn't even think about it that way, but that works. Okay, baby. Okay. If you're able to take a problem like this and put it in this form, you could just translate it into an equation, but I'll take whatever way you can think to do this. The tax is $1,600, and that's 8% of the cost of the car. Sure. How much did the car cost without tax? Did anyone come up with a way? Did I give you enough time to try this one out? Go ahead and try that out if you haven't tried it out yet.
Did you say without a calculator, or you don't?
Oh, whatever way. Yeah. I want like a setup involves some kind of reasoning, but then you can use your calculator.
Why did y times 0.08 equals what, 1600?
Okay.
And solve y.
Yeah, so this is more direct than another problem we did that was kind of a wordy problem. 8% of the car is 1600. There's no backwards thinking at all. It's not like that problem where it said I took 10% off of the cost of the hat. It's now $20. So you had to think backwards. This is much more direct. 8% of what is 1600. That's basically how I could translate that. And then I could do it, is a of whatever. I didn't say how to use an equation, but I would do this as 8% of what is 1600. And then of course I would just divide. And now you can do the little trick, once, twice. 16 divided by 8 is 2, and then you have 1, 2, 3, 4 zeros. So it was $20,000 to begin with. You guys got it with me? I know you're gonna have calculators. I'm still could ask you to show me the work in some situations, and you can check it with the calculator. The next problem is the one where we have to think about things backwards. Because I tell you what it is after I marked up the price, and then I want to know what the original price was, right? To me, the easiest way to do number 5 is $2,002 is what percentage of the original cost? So the original cost is 100% of the original cost. That is a bold statement I'm making. So this equals the 2002 is 110% of the original, yes? If it would have been a 10% discount, it would have represented 90% of the original. Does that make sense? So if I mark something up by some percentage, where I end up must be 100 plus that percent of the original. I've added 10% to what was 100%, so of course it's 110%. Is that the only way to do this problem? No. But they all end up here. So 2002 came from a full, let me show you the way you get there. A full price, because I don't know what the original price is, do I? Plus 10% of the price. Now what is x plus 0.1x? Yeah, there's a 1 in front, so it's 1.1, which is 110%. So I can say 2002 is 110% of what? If I go straight to this question, I can then go straight to that equation, yes? 2002 is 110% of times what? X. And then I just have to divide, okay. And then, whatever the hell that is. I don't know what it is. I can't remember, do you get a decimal?
Yeah.
Yeah, what do you get?
2,202.2.
2,202?
And 2.
That can't be though.
Oh, maybe I put it.
Yeah, it should get smaller, right?
1,820.
1820?
Yeah.
No, no.
Okay.
Why would they make the price more expensive? I was saying, like, why would they make the price more expensive?
Oh, because they bought it. If I'm a store,
That's why I did it wrong, because I thought it I read marked down.
so what does every store do in their universe, especially the bookstore, for example? If you buy something somewhere else in the bookstore, you're going to buy it for cheaper, because what does the bookstore do immediately when they buy it? They immediately apply a markup, so they make a profit. So this is like the company got it for $2,002 directly, and then they marked it up before they sold it. And what they'll do often is they'll mark it up by 10%, and then they'll give like a discount, but overall they're still making profit. Okay, so these are the kind of questions that I don't like to ask, these nuts and bolts things. There could be some conceptual questions, but very often I like to do this kind of problem. Maybe not this big, because we got a lot of other stuff on the test. And then something like one of these guys. You know me, so more than likely something like down here. Maybe. Okay. So if everybody has a practice test, now I will open it up to whatever you guys want to focus on. Is there a problem from the practice test you want to look at? Is there a problem from homework you want to look at? Yes.
Can you look at number 18 from the practice test?
Oh. Oh yeah. So, this is all there is. And then whatever I'm looking at, this is all that exists. 15 dogs, 12 cats, 3 pigs. I want to know the ratio of dogs to cats. So, there's a few different ways you can write this. You can write it as a fractional thing. I think on the answer key I wrote it as a ratio with a colon. I'll accept either way. So you literally just have to do, how many dogs are there? 15. For every 15 dogs, there's how many cats? 12. So the ratio of dogs to cats, you can write it like 15 to 12, like this. You can write like 15 to 12, like that. Now, real quick, when you're teaching ratios, what is weird about that fraction? What kind of fraction is it? Improper. But isn't it still talking about a part of everything? How can it be bigger than 1? So yeah, so one thing I said there wasn't quite right, because what number do I not see showing up in there? It's not really a fraction. It's not a part of a whole, is it? What should be on the bottom if it was a part out of a whole?
The 50, 12, 3.
Yeah, total number of animals. Then it would tell me how many out of the total number of animals, how many are dogs, right? So the percentage of the animals that are dogs. A ratio specifically just says the relationship between two amounts. It doesn't have a relationship between the amount, the part, and the whole. Yes, necessarily. That is one kind of ratio you could make. In fact, I think part C, that would be more like a true fraction. Yes. So a ratio can be written as a fraction, but that doesn't mean it means the same thing a general fraction would mean. So I have to be very careful of a context. Now, one thing I did on the practice test is I actually reduced the ratio. If for every 15 dogs there's 12 cats, how can I reduce that?
5
For every 5 dogs there's 4 cats. Yep. And then I could ask a question like, if that ratio holds and they now have 20 cats, how many dogs do they have? How would you do that? The ratio holds. They buy more animals. The ratio holds. They now have 20 cats.
Multiply both sides by 5.
Yeah, because how do you, to make 4 become 20, you got to multiply by 5. And you got to multiply that. So now they would have 25 dogs. And I'm definitely not going in there. No. And of course, the rest of them work the same way, right? Pigs to dogs would be what? 3 to 15. Yes, you can do 3 to 15, or you can do 3 out of 15. This is still read as 3 to 15. I gotta be careful. Cats to all animals, that's the one that's most like a real fraction. What would that be? 12 out of 30, 12 to 30. Yeah. And then you can reduce that. Okay.
What's a reciprocal?
Yeah, what's a reciprocal?
It's the
It's another name for the multiplicative inverse, yeah. So multiplicative inverse just means the number I multiply to get 1, and it's always the reciprocal. That's what I multiply to get 1. So it's just another name we use for it, yeah. So where'd that come up? Was that up here? Oh yeah. All right. So what's really funny to me, I always have to catch myself because I was about to say, what mistake do you think students make on this? And then I realized some of you guys might be one of those people that would make this mistake, but how should you do this?
Turn it into an improper pattern.
Turn it into improper, because I can't turn it over until I get something that's got a bottom and a top. And currently, I got something at top and a bottom and a side. That doesn't work. I can't. So it's technically letter of the law correct to say this, but what's wrong with that? It's gross, for one thing, but also is it a fraction? That is not a fraction. Why? A fraction is defined to be the ratio of 2 whole numbers. So the best way to do this is to turn this into a improper fraction, and then you can just flip that bad boy, right? You can understand that some students might do this. Do you see what I mean? They're like, I don't like the 8, let me just focus on the part I know what to do. Yes? Okay. Is that all right? Yes.
I have a question on homework
Yeah.
7.2.
Alright, which one?
Question 33. I think it is.
33. Oh, this guy here?
Yes,
Alright.
yes.
An absent-minded bank teller switched the dollar, get back. We can know again dollars and cents instead of dollars after buying a 5-cent newspaper. Mr. Spencer discovered that he had left exactly. Oh, okay. Yeah. Has anyone tried this one out yet? This is one of those that's getting towards the end of the section. So it's gonna be a little more bonusy. You know what I mean? Not something you can just not do, but it's definitely gonna be a little extra. So let's see. So does everybody understand the premise? So one good idea is to make sure you understand the premise, just come up with an amount, right? Can somebody come up with an amount that the check that Mr. Spencer cashed, just randomly an amount? 100 even dollars?
No, it's like $10.20.
All right, $10.20. Let's see. Do I have any paper? Rark. No, I don't. Okay. Here we go. So $10.20. So what the bank would have done is they would have given the guy $20.10, something that they would never do. Don't get excited. By the way, I don't know if this is the answer. I'm doing a random guess and check. And in the process, it is possible I just randomly got the answer. That's not impossible, but it's really unlikely. So then Mr. Spencer goes, what's the rest of this? He buys a 5-cent newspaper. I don't know what year this is coming from. So what he had left was exactly twice as much as his original check. So if he spends 5 cents, that's $20.05. Now look how close this got. It's kind of funny. Isn't that almost, come back. Is that twice as much as what he had left? I mean, is his original, sorry? Come back to me. Is that twice as much? Isn't it really close to twice as much? Okay. So maybe it's somewhere around there. Now, how would you actually figure this out? So one way is to kind of do this. Kind of try to hone in on it from a guess and try to refine your guess. We got really lucky with this one. Let's try another guess. Let's make it $35.46. So what would the bank have given him? $46.35. He goes and buys a newspaper for 5 cents. He's got $46.30 left. And you see this is nowhere near twice as much. Now, let me give you one little hint as to how to do this a little less guess and checky. Whatever this is going to end up being 5 less than it, yes? Because that is going to become the cents amount, and then he's going to lose 5 cents when he gets the newspaper. So what you're really trying to make happen is you want, and that's why this got really close. You want this minus 5 to be half of this, and you want this amount to be half of that. So that's why the 20 kind of worked a little bit. Just needs a little bit of work. I don't know if what I just said makes sense. If you think ahead of what's going to happen. So if you could do this even. So then the bank would give y point x, and then when you take 5 away, you end up with y point x minus 0.05. That looks terrible, yes? So how do I make this exactly, how did they say it? Half?
as much.
Oh, it's supposed to be twice as much. Yeah, okay. I think I might have just said something backwards, but that's okay. So the only way this could be twice as much is if y is twice x, and x minus 0.05 is twice y. I don't know if that helps any. To me, that's how I do it, but it gets a little gross. That gets very gross. It gets very algebraic-y. This is pretty close. Just kind of think from here potentially. So it kind of makes sense that you want this to be half of this, because when you turn it around, this will be twice this. That's one little thing you can keep in mind. Alright, so it's really just kind of a play around with it kind of problem. Yeah.
Number 8 on the practice test.
Let's see.
Can I look at the book real quick?
Yeah.
I had another question, but I couldn't remember which number it was.
You said number 8? 8? What is this? Oh, that's it. Oh, yeah. Did anybody try number 8? Now, this is very much like a problem you see in the book, yeah? Did anybody try number 8 on the practice test? Yes? Do you think you got it?
Maybe.
Maybe?
Oh, I got it.
You got it?
I think I did.
I got
What'd you get?
142.
Yeah. How'd you do it?
I wrote down as the fractions were going, so like 1/2.
Yes. So
And then-
whatever his estate is, he gave 1/2 of it to his wife, 1/9 to each of his 3 children. So what total amount went to his children? 1/3. So you kind of like added those up as you went?
Yeah.
Which makes sense. Yes?
Yeah, so you basically change it all into 24ths.
Yes, at the end, if you collect all of the fractional parts of this problem, kind of makes sense because the last digit is 1/24. The LCD could be 24. So you have 1/2, 1/3, and then for the grandchildren, what is it?
It's what?
3
Sorry.
24th, yes?
It's like 1/8. It's very fast.
So you got 1/2, 1/3, and then 3, what was it, sorry, 3/24, so 1/8. And yes, the LCD for 1/2, 1/3, and 1/8
It's 24.
is 24, totally. Now, real quick, there's multiple ways to do this problem. This is actually the way I did it, just because it's the first way that came to me. Notice how very little algebra I'm doing so far. I've done no algebra yet. And you don't always, algebra is just one possible tool. I want this to make sense. The remaining $18,000, that represents the fractional amount that's left after he gives all the other shit away. So if I add up the fractional amounts that's gone to certain people, I'll see what fractional amount is left. And that has to equal the 18,000. Does that make sense? So I got fractional amounts that's taken away, and then I know the total amount that's left. That amount that's left must equal the fractional amount that would have been left. So what fractional part of the estate went to other places besides charity? What do you get when you add all those together?
So 23 on 24.
Yeah, because you get 12 24ths plus 8 24ths plus 3 24ths. So you get 23 24ths. It's given away to people directly. 18,000 was given to charity. What fractional part was given to charity? 1/24. Fractional part of what, by the way? 1/24 of what? The estate value. And do we know how much that is? No, in fact, that's the freaking question. So, of course, that's 1/24 of 1/24 of something I don't know is 18,000.
So you just multiply.
And then just multiply by 24, and then you get, like you said. Now, again, that's not the only way to do this. Guess and check would be bad.
Yeah.
There's not enough restraints on this to guess and check.
432 now.
Yeah.
For number 7, I didn't understand.
Me either, that's why I asked you guys. Oh, did you not, can you not identify what they did?
No, I think that's right.
Can anyone identify what they did? Yes?
He divided
Oh.
21, 23,
Yeah.
23.
So he took the 3 and 21 and he
Divided instead of multiplied.
reduced it, right? And you can see, again, you can see why. Because what have you pummeled in these poor kids' heads up until this point? When they're sitting next to each other, you multiply, yes? And this is the one damn notation we picked to not mean that. Yes?
Can we do number 19?
Oh, real quick though, is that okay? Wait, who asked? Did you ask that?
Me.
You
Oh,
did.
yeah, I
Does
got
that
it.
make sense?
Yeah.
Okay. And then how you would explain it to the student, that's up to you. There's a lot of different ways you would explain it to them. Which one?
19.
Oh yeah. So this is another one I would accept a lot of different ways. The textbook way to do this is by setting up a proportion, right? One ratio equals another ratio. Because you have cups of flour to cookies equals cups of flour to cookies. How many of you, anybody in here bake ever? Baking, bake. You do this kind of math, yes? Yes? Almost never is the recipe in the book exactly the amount I want to make. Yes? So I've got to kind of like, and if you trust me, dude, you'll start to appreciate math the first time you try to change a recipe, just guessing. And then you're like, okay.
A lot of websites, though, they have like an option for you to change it. Though.
Yeah, it makes me cry a little bit. I'm like, the few places people have a chance to work with math, they've been taken away. So
Yeah.
automatic change, tips and all that kind of stuff. All right. Well, the tip thing, I agree with, because people just screw people over. I don't know math. Here's $1. So, how would you set that up as a proportion? And let me just say this directly. What's going to suck about this proportion is it's going to have a fraction that has a fraction in it. Oh well. So, how do I set up the proportion? This is by the book, by the way. This is not the only way to do this. So I'm gonna do a proportion flour to where'd you go? Flour to make 4 dozen, yeah, dozen cookies. Or do you guys? I can't remember now what I did. I might have done that. Let's just do cookies. Yes. So 1 1/4 cups of flour makes how many cookies? 48 cookies, yes? And the question is, so I've already designated flour to cookies. So for my next fraction, my next ratio is going to be what to what? What goes in the top? X, good, because I have no idea how many cups of flour. And what's 9 dozen? 108. And now you simplify. Yes? Yes.
On these kind of problems, can you do them however you want?
Oh
Because I
shit,
do it
yes.
differently.
So, as I said just a second ago, this is the textbook method.
Okay, that's what I thought.
This is not the way I would do it.
Yeah.
But this is the textbook method. Completely valid. You set up a proportion. You can change this into a improper fraction. Okay. Let's now real quick. How did you do it?
So I know that 4 dozen. So I know that I need a cup and a fourth of flour to make 4 dozen cookies. So it's 2 1/2 cups
Good.
of flour.
Real quick.
Eight.
To make
To make 8.
8. Beautiful. Now, real quick. So everybody get that. 1 1/4 cups to make 4 dozen. So of course, 2 1/2. Double 1 1/4. I get 2 1/2.
Yeah. So
to make
Just-
8 dozen, and of course, jackass Jeff had to make it 9. So what did you do that?
So then I just did long division to find out how much flour I would need for one dozen
Oh,
cookies.
long
so,
division.
so I did 1.25 divided by 4,
Oh,
and then I realized that I needed 5/16.
5/16.
So I added that to the.
So really quickly, 5/4 is 4, yes, 4 dozen. So if I divide by 4, and what's the same thing as dividing by 4, multiplying by 1/4? So then 1 dozen would be 5/16.
Yeah, and then I
Okay.
just added that to the 2 1/2.
And the 2 1/2, oh yeah, the 2 1/2 you got from earlier, yeah, I got you. That's more like the way I would do it.
Yeah.
Yeah. But when you do that, dear God, you have got to capture what you're doing. Yes? Don't tell me after the test, oh, here's what I did. No. It's got to be on the test. It's got to be, show me your thought process. Unless I state, set this up as an equation or something, if I just give you a problem, as long as you can capture your thought process and it makes mathematical sense, I'm good. I think, before I forget, I think last time I said this, because I've seen this in a few homeworks. What is wrong with a teacher saying, well, they got the answer right, so the reasoning must have been good? Is that a good statement to make?
Because if they took the wrong reasoning and they just happen to get it right, they're gonna get the.
Yes, and it's the worst thing in the world, trust me. When you have a student, especially I'm thinking about certain students in my head that already are kind of like, they don't like math. And then they get the right answer, but the reasoning was completely wrong. They just kind of coincidentally got the right answer. That's the worst situation. Because then, like, yeah, you got the right answer, but it's not going to work in other situations. They're like, I don't care about other situations. Give me the points for this problem. No. I could be talking about specific things like that. Is everybody okay with that problem? So you could either do it by the book. You could do it a little more feeling things out. I love it, as long as you can capture your thought process. I didn't need to drill down the cookies, by the way, but I don't know. Thought it might be easier just to work with these numbers eventually. Because 4 goes into 108, makes that a little bit easier. Yeah.
Number 5.
Oh, this guy? So I specifically want over 21. That kind of tells you what to do. If I said over 7, there'd be no answer, correct? There's no whole number between 3 and 4, bless you, so I couldn't. The fact that I said over 21, what can you do with 3 7s and 4 7s? Make them over 21. So so how do you build 3 7s up? What is 3 7s equal to out of 21?
9.
Yeah, multiply by 3, so multiply by 3, 9. So what's 4 7s?
12.
Yeah, multiply by 3, multiply by 3, 12. So now that you've done that, you can see whole number of values for the top that would be between those two.
So I can choose any of them.
Oh, hell yeah. Well, in fact, I think I said, where'd he go? Yeah, I didn't say find all. I just said find whole number of values. I did say plural. So there's only 2, right? So yeah, okay. If I had just said find a fraction between 3 7s and 4 7s, what could you guys have done? Yeah. So what would you get? 3 7s and 4 7s. You get 3 plus 4 over 14. So 7 over 14 is a half. 3 7s, you all agree, is a little less than a half? Because 3 plus 4 is 7, so 3 7s is a little less than a half. It's less than 4 7s is a little more than a half. So it makes sense that 1/2 would be between the two. But this problem specifically, I wanted it out of 21. Yeah. all right, so I'm gonna ask some questions that I thought I would get asked. What about number 1? Okay. I don't blame you, right? You're all like, what the shit's up with this guy? So when you first read through that, you can see in my question, you can see the elements over there. You might not see how they go together. What would you do to make 5y from the first thing I tell you? Yeah, so I really want this to make nothing but sense. How would you determine that that statement is true if I gave you numbers here? How would you show that this inequality is right? Wouldn't you cross multiply and see which one's bigger? Now, I told you it's less than. Therefore, when you cross multiply, what do you get? And remember, you're not really cross multiplying because we're not solving something, but I'm using the cross multiplication to do something. So when I cross multiply, I get 5y, 9x, and of course what goes in the middle? The same. If that's true, therefore this must be true, yes? Okay. That still doesn't, you're still like, okay, Jeff, great. What the shit? Can you make this expression by doing something here? Yeah, good. Yeah, subtract 5y. So over here I get 9x minus 5y, and over here I get 0. What does that say? Read it backwards. 9x minus 5y is greater than 0, which makes it what kind of a number?
Positive.
Okay. Do you guys see that?
Yeah.
And again, it wasn't a matter of, see, Carrie, it wasn't a matter of directly getting that answer. I had to realize, how do I create this statement from the only thing this guy told me? So if I cross multiply, I can then start creating that statement, and then I know something about that statement. I know something about 9x minus 5y now. Okay, maybe. And that kind of problem, listen, I understand that kind of problem drives students insane because you're all going to say something like, I never saw a problem like that. But do you see how it utilizes stuff that we've learned in a different way than you're used to? That is the goal of all mathematics is here's concepts. There's a billion ways to use them. The more you understand a concept, the more you can use it in any situation. With all that said, that's a weird little question, which is why it was cool putting it on a practice test. But what about number 2? We've seen that kind of thing before, just with fractions now. What can I do in number 2 now?
Distribute. It's basically like distributing
Yeah, undistribute, right? What can you take out?
the 9, 15, 30.
Does anyone know what the most common mistake is? Especially if we put a minus. If I put a minus in the middle, people will tell me the answer is 0. Well, what I would get from this would be 9/13 times 1 times 9/13. What mistake did somebody make?
Multiply the 9, 15. Or
That's the mistake they're about to make. How did they get to here?
They didn't use PEMDAS.
Exactly. They did not excuse their dumbass son or their dear Aunt Sally. So they added before they multiplied. That's no good. No, get out. What I get when I do minus is that I'll get that a lot. What I'll get is, especially if I write this the other way, I'll get 5/8 times 9/13 minus 9/13 to 3/8, and that's 0, of course. No, it is not. It's not 0. This one, I'm not going to say a word about. Just go away. That's a little too easy. This one's not too bad, yes. This one's pretty straightforward. These kind of problems, I have no idea how you feel about this kind of problem, but to me, these are the most important questions. Is how would you talk to somebody who has an incorrect understanding of something? This one's pretty straightforward. This one's a very common mistake. You guys can all see the mistake, yes? Okay. So you have to be ready for this kind of thing. You have to be ready with some kind of way to show them that it's wrong. How many possible answers to this would get all credit? Oh my God, so many. I have a way I would explain this, but that doesn't mean it's the way you would, and the way you would could be completely fine. There's one reason why I love this kind of question. It's the closest I can get to being an English teacher. I'm jealous of English teachers because they get to know their students better. They get to read all kinds of stuff. Very often it's kind of personal stuff that students have to write. I don't ever get that, but this is neat. Does anyone know, had an idea about how to explain this, the mistake, to a student? And real quick, let me ask you this. When a student makes this kind of mistake, what is your goal in your explanation to the student?
To not do the same mistake over.
To not do the same mistake again. Show why they're wrong, sure. But also to show, like, try to find what parts of their thinking is right. In this case, not much. To explain to the student, you understand why they made the mistake they did. It's fine. It's a human thing to do that. Okay. So there's a lot of different ways you can explain it. Is there an example you can give, or is there something that would show why it's wrong? And don't just make them into decimals and so forth. 6/7 and 9/11, which one is closer to 1? 6/7. So if you have something that's close to 1 and you add something to it, shouldn't it get bigger? And in this case, it doesn't, because 9/11 is smaller than 6/7. That's one kind of way. And again, if you just say that, that's not good enough, because that's showing the student it's wrong. It's not explaining why it's wrong. But that's a really good first thing, is just to say, here, this is, you can see it's not right. You can do this and see it's not quite right. Yeah, you could do, this specific problem would be a little gross, but yeah, you could do the rectangular approach. You can talk about how far away from a hole is 6/7. How far away from a hole is 6/7? 1/7. And so you're adding 3/4 to it. Shouldn't it be more than 1 now? You know, that kind of thing. Okay. Yes?
Are you giving up the answer key?
Huh?
Or did you give up the answer key?
Oh, I've got an answer key, which I'm worried about the people that have left already, but I guess they didn't want one. I'll go ahead and give you guys this in case anybody else wants to scoot out. Sure. So a few of my answers could be different from yours, like with the explanation stuff, and the approaches I took could be different. Oh yeah, I kept it as 4 dozen and 9 dozen. Okay. Alright, so let me know. And again, just to remind you guys, we've had several practice tests by now, but if you didn't try the actual practice test, don't just stare at the answer key. It builds up false confidence. Yes. Where we at, sorry? Oh, because I put a 10, of course, like a smart person. So here is the reason I still am averaging about a 97 on my answer keys. Where'd it go?
17.
Yeah, for whatever reason, I decided to make this tenths. So right here, this should be hundredths, which would give this one more zero, which would move this over one more spot. Now, if I were you, on the actual test, you can always just throw in the old calculator, make sure you get the right answer. This is the kind of work I would need to see though, but you can certainly put it in the calculator, make sure this is right. Something I could have done, but I didn't. Let's see. People always get tripped up when I ask for this kind of problem here. So when you use distributivity to help with something, you normally break up the problem that gives you a problem. So that would be this guy. So if you break them as 4.5, then you can do 60 times 4 and 60 times a half and add those together. Let's see, what's anything else weird?
For number 9A, do you want us to leave it as an improper fraction or switch it to?
Oh, in general, here's kind of a rule that's not like hard and fast, but if it starts with improper fractions, you should end with improper fractions. But if you made that into a mixed number, I wouldn't care, because I don't say not to, right? If you start with mixed numbers, you should end with mixed numbers. But really, the only time I take points off if I say specifically end with a mixed number, and you end with an improper fraction. That's no good. Real quick, let me see if you guys. This might not. 32 over 35. It might, I don't know. It might feel like that should be reducible potentially. But they're 3 apart, so the only way it could be reducible is if 3 went into either one of them, and it doesn't, so it's not reducible. I don't know. Just remember, the only way a fraction can reduce is by a factor of how different the top and the bottom are. So for a quick example, if I had 27 over 33, how far apart are the top and, top and bottom? 6. So the only way it could reduce is by a factor of 6. It could be 6 itself, but 6 doesn't go in. It could be 2, 2 doesn't go in. It could be 3. I think I've talked about this a couple times before, but that's kind of a cool thing to realize. If a fraction reduces, it means that both numbers were multiples of the same thing. And multiples of the same thing have to be the same distance apart, have to be a multiple apart.
When reducing, like, for example, how you did 5 and 15 and 24.
Where are we at?
The same one, 9B. It was 4 over 15, and then you reduce that to 5, and then the 24, you reduce the 24 to an 8.
Which one? I'm sorry. Oh, this one.
Yeah. You can't do it straight across on.
Oh, here,
4,
this one.
Like
Sorry.
4 and 24, you can't reduce like.
Definitely not.
Yeah.
The reason that reducing works in the first place is if it's on top, it's multiplication. If it's on the bottom, it's division. And the only way you can cancel anything in the universe is if the operations are opposite. So if they're both on the top, they both mean multiply. There's nothing that would make them cancel. But if one thing is on the top and one thing's on the bottom, they're opposite operations.
Yeah, because I think I did it when it was like.
Oh, before you flip.
Yeah.
And again, this is division, so it can't cancel multiplication. Yeah, you can't, you need opposite operations. So division can't cancel division. But once I flip it, now division can cancel multiplication all day, yeah. that's not right. I'm not sure what I was doing. Real quick, on number 11, what's the most important thing there, if I ask that kind of question? Number 11.
Wait, what is that?
The fact that you wanted words that I would think that. Well, the most important part of changing the words. Hmm?
Put the s at the end.
Say again?
Put the s at the end.
Oh,
That's a
sure.
good one.
That's a good one. That's a good one.
Okay.
But where do I put the word and? That's the most important.
You gotta mark down if you say point instead of and.
Yes.
Oh, yeah, I was about to say.
20 points. 20
Failable
hands.
test.
What do the decimal thing?
Put dot. Put dot and see how that goes.
Period.
9.587.
Yeah, what is this test?
Good. Good to know. See you.
Almost got it on my homework, guys.
All right.
See you Thursday.
See you. Do you have questions? No? Okay. If not, that's fine too. Trust me.